press the bell icon on the YouTube app and never miss another update.
Hello students, today the topic is the chemical properties of potassium permanganate. Already we finished the preparations and structure regarding potassium permanganate, how to prepare potassium permanganate in the laboratory, and in industrial method how it was prepared, and what about the general physical properties, and what happens when potassium permanganate on heating. Already we studied in last class. So next last topic in D block elements. This was very important for a competitive point of view, so don't neglect. So listen carefully and practice the balanced chemical equations. Practice balanced chemical equations with respect to the oxidation of reaction and reduction of reaction. Because of potassium permanganate is act as a strong oxidizing agent. KMnO4 is act as strong oxidizing agent. What are the oxidizing agents and what are the which reaction when it undergoes oxidation in acidic medium or undergoes oxidation in a neutral or basic medium, which reactions takes place, how many electrons transfer from reactants to products, now we have to discuss. So here this was the last topic regarding D block elements. So permanganate properties, the D block elements, properties of KMnO4. Remember already last class I said that potassium permanganate is purple color, diamagnetic, manganate is green color, paramagnetic. Both are tetrahedral structure, both are having sp3 hybridization. Remember these 2 points, very important. Permanganate purple color, diamagnetic, tetrahedral sp3. Manganate green color, paramagnetic, tetrahedral sp3. On heating permanganate, it liberates manganate. KMnO4 gives rise to K2MnO4 plus MnO2 plus O2. This reaction very important. 2KMnO4, permanganate we should heat, then we will get K2MnO4 plus MnO2 plus O2, liberate O2. On heating potassium permanganate, is liberate potassium manganate along with the manganese dioxide and oxygen will be liberated. So here this potassium permanganate is act as a powerful oxidizing agent. So it oxidizes which type of salts? Those are important in acidic medium or neutral or alkaline medium. These are very important reactions. In acidic medium, how the reaction takes place. In alkaline medium, how the reaction takes place. So before that, you should remember balancing redox. We have to follow some rules. Add H plus towards H atoms are less. And add water molecules towards O atoms are less. This area in acidic medium. In acidic medium reaction, balancing redox reaction, oxidation of reaction or reduction of reaction, any of reaction you should balance like this. Add H plus atom towards H atoms are less, add water molecules towards O atoms are less. And next alkaline medium. What to do? Add water molecules towards H atoms are less. And add OH minus ions towards O atoms are less. These points keep in your mind, then balancing was very easy. Without these points balancing was very difficult. After hydrogens, after oxygen balancing, after hydrogen balancing, how to balance charge, negative species, electron losers, positive species, electron acceptors. These are the basic fundamental points already we studied in first PUC. So no need to bother about this. So simple. Once you revise, once you revise, then you will get an idea about this. KMnO4 is act as a strong oxidizing agent. KMnO4 is act as strong oxidizing agent. So here, according to this information, we have to balance some chemical reactions, and KMnO4 oxidizes which type of species. Now we have to discuss. Those are the very important for board as well as competitive point of view, also very important it is. And before that, on the basis of electrode potentials, on the basis of electrode potentials means already we know that MnO4 minus plus 1 electron gives rise to MnO4 2 minus. Permanganate, addition of 1 electron to permanganate. Addition of 1 electron to permanganate, we will get MnO4 minus 2. This is called as manganate. What will be the Enard value for this one? Enard value 0.56 volts. Enard value is 0.56 volts, means it is less positive. More positives, strong oxidizing agents. Less positives, weak oxidizing agents. Negatives, reducing agents according to the electrode potential values. According to electrode potential values, we have to find like this. And the next one, same MnO4 minus plus 4H plus 3 electrons gives rise to MnO2 plus 2 to the 4 2H2O, and in this case Enard value is equals to 1.52 volts. In this case, what is Enard value? 1.52, not 1.52 here, 1.69, 1.69 volts, right? 1.69 volts. What about this electrode potential value? Electrode potential value is MnO4 minus plus 4H plus 3 electrons gives rise to MnO2 plus 2H2O. MnO2 plus 2H2O, here what will be the Enard value is? Enard value is 1.69 volts. 1.69 volts, and one more is equation also there. MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O. Here electrode potential value is 1.52 volts. So why necessary to discuss about these things? What will be the importance to discuss about this thing? Means already we know that electrode potentials positive electrode potentials act as oxidizing agents. Negative electrode potentials act as reducing agents. In this case, potassium permanganate acts as strong oxidizing agent. Potassium permanganate acts as strong oxidizing agent. Once you observed in this, without a hydrogen ion concentration, the electrode potential values are only less electrode potential 0.56. So these reactions are influenced by the concentration of hydrogen ion. These reactions are influenced by the concentration of the hydrogen ion. See this 4H plus 8H plus. Reactions are influenced by the concentration of hydrogen ion, and here so according to the concentration of hydrogen ion, then we have to give one confirmation regarding potassium permanganate oxidizes water molecules to 1m H plus concentration. Potassium permanganate oxidizes water. Potassium permanganate oxidizes water at 1m concentration of hydrogen. KMnO4 oxidizes water at concentration of H plus is equal to how much? 1 molar concentration of hydrogen ion. 1 molar concentration of hydrogen ion. Because of these reactions are influenced by the concentration of the H plus ions, and due to that while once the rate of reaction becomes very slow, according to chemical kinetics, according to thermodynamically, the rate of reactions values are very slow. To speed up the reactions, we require some temperatures. To speed up the reactions, we require some temperature or catalysis we required. So, what will be the necessary for this reaction? Discussion for this reaction means electrode potential values. Electrode potential values are participating a major role for deciding a substance or a species which is act as oxidizing agent or reducing agent. So, according to these electrode potential values, so these are act as oxidizing agents. So, potassium permanganate act as strong oxidizing agent in acidic medium and in alkaline or neutral medium. Alkaline or neutral medium, it is act as oxidizing agent. So, according to the electrode potentials also said that it oxidizes water at 1 m concentration of H plus ion. So, here you should remember one standard equation, not one standard equation, two standard equations are there. The two standard equations are very important, are very deciding factor to balance the overall reaction. What reactions we discussed now? It was means simple here. Number one, in acidic medium, you should remember this MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O. In acidic medium, it is a reduction of reaction. In acidic medium, MnO4 minus convert into Mn2 plus. MnO4 minus converted into Mn2 plus. MnO4 minus converted into Mn2 plus. Reaction takes place in acidic medium. 4 oxygens are there. You should add 4 water molecules. 4 to the 8H plus you should add left side. After adding here 8 electrons, here minus 1 electron, here plus 2 electrons. So, overall how many electrons means by adding, subtracting, what will get the final electrons are 5 electrons. So, here my dear students, this is very important, standard and branded reaction in acidic medium potassium permanganate. Permanganate ion gives rise to manganese 2 plus ions. Permanganate ion gives rise to manganese 2 plus ions in acidic medium. So, this standard and branded reaction you should fix it in your mind. Clear? This is a reduction of reaction, remaining will be the oxidation of reactions will be there. By adding reduction of reaction, oxidation of reaction, we will get a total reaction. So, in acidic medium, MnO4 minus plus 8H plus 5 electrons gives rise to Mn2 plus 4H2O. And which species undergoes oxidation? Which species undergoes oxidation means already last class we discussed some examples regarding this. Number 1, I will give C2O4 2 minus. C2O4 2 minus is called as oxalate. C2O4 2 minus is called as oxalate. Oxalates oxidized to carbon dioxide. Oxalate oxidized to carbon dioxide. Nitrites oxidized to nitrates. Fe2 plus oxidized to Fe3 plus. SN2 plus oxidized to SN4 plus. I minus oxidized to I2. Sulfides oxidized to sulfates. Sulfide oxidized to sulfur. Already last class we discussed these all reactions with respect to the potassium dichromate. But in this case, the example was different. It was potassium permanganate. Potassium permanganate oxidizes oxalic acid to carbon dioxide. Nitrite ions to nitrate ions. Ferrous ions oxidized to ferric ions. Stannous ion oxidizes to stannic ions. Iodide ions are oxidized to iodine. Sulfides oxidized to sulfate. Sulfide oxidized to sulfur. Sulfide oxidized to sulfur. Let us consider one example. Number 1 is C2O4 2 minus oxidized to what it is? CO2. Oxalate ions are oxidized to carbon dioxide. Oxalic acid oxidized to carbon dioxide. Already this is one of the volumetric experiment was there in laboratory. Already more of the all the students are done. I think it was MnO4 was filled in burette and pipette out to oxalic acid and add 20 ml or some amount of H2SO4 to that. After that titrate against KMnO4 at a particular time that colorless solution is converted into pale pink color. So that will be the end point. So that only reaction, what reaction means oxalic acid, on that reaction oxalic acid is oxidized to carbon dioxide. So what is the standard reaction? Standard reaction MnO4 minus plus 8H plus 5 electrons. MnO4 minus plus 8H plus 5 electrons gives rise to Mn2 plus 4H2O. This is standard reduction of reaction. For this standard reduction of reaction, you should add oxidation of reaction. What is oxidation of reaction? Number 1, oxalic acid, oxalate ions. Oxalate ions oxidize to liberate which gas? CO2. So here number 1 we should discuss first. C2O4 2 minus gives rise to CO2. C2O4 2 minus gives rise to CO2. Before balancing oxygen and hydrogen, first we have to cross check constant atoms. What are the constant atoms? In this example, carbon is constant. Here 1 carbon atom is there, here 2 carbon atoms are there. So you should add 2 CO2. C2O4 2 minus gives rise to 2 CO2. Number of oxygens left side 4 oxygens. Number of oxygens right side 4 oxygens. So there is no need to add water molecules and no need to add H plus ions because it was balanced. Because number of oxygen atoms are same while adding 2 number. Because of here 2 carbon atoms are there, 2 carbon satisfied with 2 carbon atoms only. And next we have to balance charge balance. So here 2 minus was there. 2 minus means removal of 2 electrons. Removal of 2 electrons we should write like the C2O4 2 minus. This side we should write 2 minus. Otherwise if you in chemical equations we are not represent minus number. Due to that reason in textbook there was given you took this minus 2 electrons that side. Then it was plus 2 electrons. C2O4 2 minus 2 electrons gives 2 CO2. Or for our convenient we should write like this. For our convenient we should write minus 2 means removal of 2 electrons from this. So it is the equation 2 you decided it is. This is equation 2 and it is equation 1, Branded equation. Branded equation is 1. Branded equation 1, yesterday last class also I was given one Branded equation, that is Cr2O7 2 minus plus 14H plus 6 electrons gives rise to 2Cr3 plus 7H2. This is also which medium it is? Acidic medium, branded. This is also branded, very important. Fixed it is branded equations. These are reduction of reaction. Branded equations are 1 you said. This is branded equation 1 with respect to the potassium dichromate. But here branded equation, what is branded? MnO4 minus plus 8H plus 5 electrons gives Mn2 plus 4H2O. And what about the oxalate ions? C2O4 2 minus 2 electrons gives 2 CO2. In equation 2, 2 electrons, equation 1, 5 electrons. Then what to do means multiply with 2, multiply with 5. Then number of electrons 10 get cancelled. Remaining equation is said to be balanced equation. This equation multiply with 2. This equation multiply with 2 means what will be the balance equation? 2 MnO4 minus plus 16H plus. No need to write electrons because electrons get cancelled. While coming to left portion this side, this equation multiplied with 5 plus 5C2O4 2 minus gives, because electrons get cancelled. Next coming to right side, 2Mn2 plus and number of carbon dioxides 2, multiply with 5, second equation multiply with 5, 10CO2 while coming to this 4H2O, 4 into 2, 8H2O. This is a balancing equation with respect to the potassium permanganate. 2 molecules potassium permanganate required, 5 molecules of oxalic acid, 1 mole potassium permanganate required, 5 by 2 moles of oxalic acid. But for some numericals, we have to use these values, coefficients. Coefficients are useful to calculate some numericals. So 2 moles MnO4 minus required, 5 moles of oxalic acid. So this is the balancing equation, 2 MnO4 minus plus 16H plus 5C2O4 2 minus gives rise to 2 Mn2 plus 10 CO2 plus 8H2O. So it is balanced equation with respect to the oxalic acid. Potassium permanganate oxidizes oxalic acid to carbon dioxide. Oxalic acid to carbon dioxide. Similarly, moreover reactions are there. Nitrites oxidized to nitrates. Iron 2 oxidized to iron 3. Stannous oxidized to stannic salts. Iodides oxidized to iodine. Sulfides oxidized to sulfate. Sulfide oxidized to sulfur. Sulfide oxidized to sulfur. So here all examples are followed by this technique only. This is a standard and branded equation. So no need to touch this one. We have to interchange this only. Let us consider second example. Second example is what? NO2 minus gives rise to NO3 minus. Nitrites oxidized to nitrate. Nitrites oxidized to nitrate. So here what will be the reaction regarding oxalic acid reaction? So I will give that clear equation. Oxalic acid two MnO4 minus plus 16H plus 5C2O4 2 minus gives 2Mn2 plus 10CO2 plus 8H2O. This is a oxalic acid oxidize to CO2. Oxalic acid oxidized to CO2. Oxalic acid oxidized to CO2. This is branded. Give one special box. Give one design box for this branded. Second one. NO2 minus oxidized to NO3 minus. NO2 minus oxidized to NO3 minus. Nitrogen, same number of nitrogens takes place left side, right side. Over here 2 oxygen atoms are there, here 3 oxygen atoms are there. Oxygen atoms are less, you should add water. Hydrogen atoms are less, you should add H plus ions. So here we should write NO2 minus plus H2O gives rise to NO3 minus, number of hydrogens 2, so it is 2H plus. Number of hydrogens 2, it was 2H plus. Here minus both charges cancelled. 2H plus required how many electrons? 2 electrons. According to the simplification, after simplification, what will be the final equation we will get? Final equation we will get NO2 minus plus H2O gives rise to NO3 minus plus 2H plus 2 electrons. 2H plus 2 electrons. Nitrites oxidized to nitrate. In standard equation 5 electrons are there. In second equation 2 electrons are there. Again you should multiply same what we observed in MnO4 minus versus oxalic acid. What we observed in MnO4 minus versus oxalic acid, same repeat. Same repeat means what will be the second equation? Nitrites oxidizes to nitrate. Nitrites oxidizes to nitrate means 2 MnO4 minus plus 16H plus 5 NO2 minus. Instead of oxalate ion, you should write nitrite, because of in oxalic acid reaction, in nitrite reaction, same number of electrons. Same number of electrons means just we can exchange the reactants. NO2 minus gives 2Mn2 plus 5NO3 minus plus 8H2O. This is the balanced equation. Nitrites oxidized to nitrates. Nitrites oxidized to nitrates. Why I was select this equation only because of both examples can have same number of electrons. Branded equation 5 electrons, there is no change for this. Approaching reaction, approaching oxidizing species also contains same electrons means same number we should multiply. 2, it is multiplied with 2 and this is multiplied with 5. Again we will get 5 and here 5H2O we will get, sorry here 5H2O and here 10H plus. So, a little bit change here with respect to the here 5H2O and here into 5 means 10H plus, and in this one how many H2Os are there? 4 H2Os are right side, 5 H2O will be left side, then only 1 H2O, 1 water molecule takes place, and next 10H plus right side, 8H plus left side, so here we will get 2H plus. 2H plus. Only the change in water and H plus ions. There is no change in nitrites, nitrates, oxalates, carbon dioxide. Carbon dioxide 2 molecules. So here like that you should add. Then again you will get same number of nitrate ions. Same number of nitrate ions. Same number of oxalate ions. So because of in this equation also, how many electrons involving in this equation means 2 electrons involving in this equation. 2 electrons. 2 electrons means we should to avoid that confusions we will do one thing. Here H2O, 2 electrons multiply with 5. Then we will get here 5NO2 minus plus 5H2O gives 5NO3 minus plus 10H plus 10 electrons. What is the standard equation? 2MnO4 minus plus, so not 2MnO4, 2MnO4 minus multiply with 2 it is plus 16H plus 2MnO4 minus plus 16H plus 10 electrons gives rise to 2Mn2 plus 8H2O, and adding this to 10 electrons get cancelled. 5H2O, 8H2O means H2O 3 H2O will get right side, and 16H plus 10H plus means again we will get 6H plus at left side, and 2MnO4 minus plus 5NO2 minus gives rise to 2Mn2 plus 5NO3 minus. Then you can do like this. Again we done mistake here, see this. So 6H plus 3H2O like this. So after balancing you have to join the two oxidation of reaction and reduction of reaction. So nitrites oxidizes to nitrate, nitrites oxidizes to nitrate. So this will be the balance. And while coming to one more example, still we have to discuss one more regarding this oxidizing property of potassium permanganate, that is sulfites. Sulfite oxidized to sulfate, sulfite SO3 2 minus, sulfate SO4 2 minus. Here 3 oxygens, here 4 oxygens, which is related with nitrite. 2 oxygens, 3 oxygens, 2 oxygens, 3 oxygens, nitrate, like that. Sulfite SO3 2 minus, sulfate SO4 2 minus, same nitrite minus 1 charge, nitrite minus 1 charge. Here also sulfite minus 2 charge, minus 2 charge. So it required one water molecule, you should add SO3 2 minus plus water is equals to SO4 2 minus addition of 2H plus 2 electrons. Same reaction we found with respect to the nitrites. Nitrite sulfides are followed in same mechanism, same products, same process. So here equation multiply with 5, equation multiply with 2. Multiply with 5 means we will get 5SO3 2 minus plus 5H2O gives 5SO4 2 minus plus 10H plus 10 electrons. What is equation 1? 2MnO4 minus plus 16H plus 10 electrons gives rise to 2Mn2 plus 8H2O. Like already one equation we done, now only 10 electrons get cancelled, 10H plus 16H plus means 6H plus 5H2O, 8H2O, 3H2O. So simply here, without knowing that, we should write like this: sulfides SO3 minus, sulfide oxidizes to sulfate. What is sulfate? SO4 2 minus. What is equation? Same equation, 2MnO4 minus plus 6H plus 5SO3 2 minus, 5SO3 2 minus gives rise to 2Mn2 plus 5SO3 SO4 2 minus plus 3H2. In textbook total balanced equations are given. So for examination point of view, you should practice like this only. Practice like this means first you have to keep this equation in your mind. Branded equation MnO4 minus plus 8H plus 5 electrons gives rise to Mn2 plus 4H2O. In acidic medium reaction, this is not alkaline medium, it is. This is an example for acidic medium reaction. Suppose one more example also there regarding this, one more example. After sulfides, ferrous salts, green ferrous salts are oxidized to yellow ferric salts. That will be the last equation regarding this oxidizing property. We will explain, we will discuss about this. Fe2 plus green ferrous salts oxidized to yellow ferric salts. So here there is no hydrogen atoms, no oxygen atoms, so no need to worry about this, but only we have to balance the charge here. Fe2 plus 2 electrons gives rise to Fe3 plus 3 electrons. So what is overall electrons means, here you took 2 electrons this side, you will get finally Fe2 plus gives rise to Fe3 plus electron. Multiply with 5 only, multiply with 5, because here how many electrons are there? 5 electrons are there. 5 electrons get cancelled, remaining as it is you should write. What is remaining as it is means, number 4, Fe2 plus salts oxidized to Fe3 plus salts. So that is MnO4 minus as it is plus 5 Fe2 plus 8H plus gives rise to Mn2 plus 5 Fe3 plus 4H2O. So like this reactions are very important for board as well as competitive point of view. So you should revise these equations. Potassium permanganate is act as strong oxidizing agent. It oxidizes oxalic acid to carbon dioxide, nitrate ions to nitrate ions, sulfate ions to sulfate ions, ferrous ions to ferric salts, stannous salts to stannic salts, sulfides to sulfur, sulfide to sulfur. Sulfide means H2S. H2S is oxidized to sulfur. Iodide I minus to I2. I minus you consider, suppose I minus there was given. I minus gives I2 means simply you should add 2I minus. 2I minus means minus 2 electrons. Minus 2 electrons means already here 5 electrons, here 2 electrons. This equation multiply with 2, it equation multiply with 5. Then we will get 10I minus 5I2. Clear it is. 10I minus 5I2 we will get according to the balancing equation, according to the electrons. So these reactions are said to be oxidizing behavior of potassium permanganate in which medium it is? In acidic medium, and in alkaline medium, neutral medium or fairly alkaline medium, MnO4 minus is act as oxidizing agent. MnO4 minus act as oxidizing agent in alkaline medium also. Then what are the reactions regarding that alkaline medium? After that, what are the uses of KMnO4? Those are the last properties of potassium permanganate. So, you should practice only correct way to find the answers, because of it is totally balancing redox reactions, a little bit time takes place. So, to avoid confusion you should practice, then you will get a proper idea regarding this. So, here next one is a oxidizing property in a alkaline or neutral medium. Oxidizing property in alkaline or neutral medium. What will be the branded equation? Branded, again we should write branded. MnO4 minus plus 2H2O plus 3 electrons gives MnO2 plus 4OH minus. MnO4 minus plus 2H2O plus 3 electrons. 2H2O plus 3 electrons gives rise to MnO2 plus 4OH minus. So, this is the equation. MnO4 minus gives rise to MnO2. This is the alkaline medium or a neutral medium also is considered. MnO4 minus gives rise to MnO2. Actually, one more equation also there, MnO4 minus gives rise to MnO4 2 minus. MnO4 2 minus. So, here we do not consider that according to our syllabus. MnO4 minus potassium permanganate. Potassium permanganate is reduced to manganese dioxide. Potassium permanganate is reduced to manganese. Potassium permanganate is converted to manganese dioxide. Here plus 7 oxidation number, plus 4. Plus 7 to plus 4 decreases. Decreases means it is a reduction reaction. Reduction reaction. So, KMnO4 is act as a oxidizing agent in alkaline medium. Which medium this is? Alkaline medium. So, here alkaline medium, what are the conditions? In alkaline medium conditions, addition of water towards hydrogen atoms, addition of OH minus towards where oxygen atoms are less. So, here 4 oxygen atoms are there, here 2 oxygen atoms are there, still we require 2 more oxygens, that is why we should add 4OH minus right side, here you should add 2 water left side. Simple it is. So, already how to adding already we done in first PUC, so no need to think about that. Simple, you should keep this equation in your mind. This equation keep in your mind, because of this is very important. So, it is for basic medium. In acidic medium 5 electrons are involving. In basic medium 3 electrons only involving. In basic medium how many electrons only? 3 electrons are involving. Here what are the reactions? What are the reactions means number 1, very important, this is iodide. Iodide oxidizes to iodate. What is iodide formula? I minus. Iodate formula IO3 minus. IO3 minus is called as iodate, I minus is called as iodide. Then we have to balance this I minus to IO3 minus. Already we know that I minus gives rise to IO3 minus. Here 3 oxygens are there, here no more oxygens are there. Where oxygen atoms are less, you should add OH minus. Hydrogen atoms are less, you should add water molecule. So, how to balance means you should add here 6 OH minus and here you should add 3 water. See this equation, my dear students. I minus gives rise to IO3 minus, 3 plus 3 6 oxygens, here 6 oxygens, 3 to the 6 hydrogens, here 6 hydrogens. While adding oxygens, hydrogens, you should twice like that. 3 water molecules if you are adding, you should add 6 OH minus here. 2 water molecules adding here, 4 OH minus we required here. Understand? 2 water molecules required, 4 OH minus. 3 water molecules required, 6 OH minus. Like that, while in practice, then we will get idea about this. Then here minus 6 electrons, here minus 1 electron, here minus 1 electron. This minus 1 both are opposite, so get cancelled. So how many electrons here? Minus 6 electrons are there, minus 6 electrons. Minus 6 electrons means we should write this equation I minus plus 6OH minus gives IO3 minus plus 3H2O plus 6 electrons, equation 2. I minus plus 6OH minus gives IO3 minus plus 3H2O plus 6 electrons. In equation 1, 3 electrons. Equation 2, 6 electrons. So, equation 1 multiplied with 2. Equation 1 multiplied with 2 and equation 2 multiply with 1. Multiply with 1 means as it is we will get equation 1 multiply with 2 means we will get 2MnO4 minus plus 4H2O plus 6 electrons gives 2MnO2 plus 8OH minus. On adding these two, 6 electrons get cancelled. 4H2O, right side 3H2O means only 1 H2O here, right side. And 6OH minus, 8OH minus, again we will get what will be the equation? 2MnO4 minus plus I minus plus 2MnO4 minus plus I minus H2O, number of H2Os, only 1 H2O this side, sorry, 1 H2O left side, and it gives rise to 2MnO2 plus IO3 minus plus 2OH minus. This equation was there in your text. This equation was there in your text. So, how that equation was derived? How that equation was derived means with respect to this. So, make a note. 2MnO4 minus plus I minus plus H2O gives rise to 2MnO2 plus IO3 minus plus 2OH minus. So, what will be the reaction? Iodide. Iodides oxidizes to iodate. Iodides oxidized to iodate. In which medium this is? Alkaline medium. Thiosulfate oxidized to sulfate. Thiosulfate oxidized to sulfate. Mn2 plus ions. Mn2 plus ions are oxidized to MnO2. These three reactions which are there in NCERT are favored in which medium it is? Alkaline medium or neutral medium. Number 1 is iodides oxidized to iodate. Iodides oxidized to iodate. Second one, thiosulfate. Thiosulfate formula S2O3. S2O3 2 minus ion is called as thiosulfate. Thiosulfate ions oxidized to thiosulfate. And manganese 2 salts. Manganese 2 salts also oxidized to MnO2 in which medium? Neutral or fairly alkaline medium. So, these are the chemical properties of potassium permanganate, and what the reactions takes place with respect to iodides and what about that thiosulfate and manganese salts. So, here number 1 iodides oxidized to iodate, the equation is 2MnO4 minus plus I minus plus H2O gives rise to 2MnO2 plus IO3 minus plus 2OH minus, and the next one is thiosulfate to sulfate. H2O3 2 minus 2, H2O3 2 minus to SO4 2 minus. So, H2O3 2 minus to SO4 2 minus. So, what will be the balance equation here? MnO4 minus and what will be the balance before that? H2O3 2 minus gives rise to SO4 2 minus. Balance sulfur first, 2 balance 2 2 balance 2 4 is 8, but here only 3 oxygens are there. 3 oxygens means we required still how much? 4 2s are 8 oxygens. 8 oxygens, 3 oxygens, 5 OH minus. 5 OH minus means 6 OH minus. Suppose you consider here 6 plus 3 9. Here 1 H2O you consider. 3 H2O. 3 to the 6, 2 4 the 8 plus 3 11. Here 6 plus 3 9. Then 9 OH, 9 3 12. 6 H2O, 6 12. 12. 6 2 4 the 8 plus 8 9 10 14. 14 will get 15. 15 14 2 4 the 8 3. 2 4 the 8 3 12 OH minus 6 H2O. 6 2s are 12 hydrogens, 12 hydrogens. 12 plus 3 15 oxygens, here 6 oxygens, 2 4 the 8 plus 6 14 oxygens only we will get. 14 oxygens means we should add like this only. 9 3 12. If 9 3 12 means 9 9 H2O, how it is possible? 5 H2O suppose. 5 2s are 10. 10 plus 3 13. 4 to the 8 plus 5 13. Nice, right. This is right. S2O3 2 minus plus 10 OH minus. S2O3 2 minus plus 10 OH minus gives 2SO4 2 minus plus 5 H2O. 2SO4 2 minus plus 5 H2O. This is the balanced equation. So in this equation here minus 2 electrons get cancelled. So how many OH minus will be there? 10 OH minus. 10 OH minus means minus 10 electrons. Overall, how many electrons are involving in this equation is 10 electrons are involving in this equation. In standard equation, how many electrons? 3 electrons. Then how we will get 3, 10 plus 3, 13. 5 2s are 10, 10. S2, S2. Minus 2, sorry. So, 10 OH minus 5 H2O, right. S2O3 2 minus plus 10 OH minus gives rise to SO4 2 minus plus 5 H2O. Here 2 to the 4 electrons you should remove. Here minus 10 electrons. Here minus 2 electrons. So here total how many electrons total involving in this equation means minus 10 minus 2 minus 12. Minus 12 here 2 to the 4. This 4 you took this side, then plus 4. Plus 4 means 12 minus 4, 8 electrons are involving. 8 electrons involving means overall here you took that is plus 8 electrons. So this equation multiply with 3 and this equation multiply with 2. Standard equation multiply with 2 and second equation multiply with 3. Then you will get the correct balanced equation regarding this. What about that here? You should imagine this is 3S2O3. It is 3 10s are 30 and here 3 8s are 24, it will be cancelled. So it is 3 to the 6 and 3 5s are 15. And while coming to that one is how much? 2MnO4 minus 4H2O. How many electrons involving here? 2MnO4 minus plus 4H2O plus 8 electrons. Mm-hmm. 3H2O3 2 minus 3OH minus 3OH minus. How it is 3OH minus? 10OH minus 30OH minus 30OH minus 8OH minus 30OH 8OH means we will get to 3 8H2O 8. 2MnO4 minus plus 4H2O plus 3S2O3 2 minus plus 30OH 8OH 24OH will get 24OH means just wait, 2Mn gives rise to 2MnO2 plus 2MnO2 plus 8OH minus 8OH minus 8 OH minus. Suppose for this 8 electrons we will get 3. How many is 8 electrons? Just a minute. H2O3 minus plus 10 OH minus gives rise to SO4 minus plus 5H2O. SO4 minus plus 5H2O. Total how many? Minus 12. Minus 12 means 4. 12 minus 4, 8 electrons involving. 8 sorry. 8 electrons. So it is multiply with 3. It is multiply with 8. So clear, students? Multiply with 3 and multiply with 8. Don't get confused while balancing. So you will get here 8 MnO4 minus plus 16 H2O plus 24 electrons gives 8 MnO2 plus 24 OH minus. And second one is 3 S2O3 2 minus plus 30 OH minus gives rise to 3 to the 6 SO4 2 minus plus 15 H2O. So here electrons get cancelled here. 16 H2O, 15 H2O means 3 H2O will be there, and 30 OH minus 24 OH minus means 6 OH minus will be there. While adding this to 8 molecules MnO4 minus required, 3 molecules thiosulfate. 8 molecules MnO4 minus required, 3 molecules thiosulfate. On the basis of this you have to 8 4 is 32, sorry it is 8 4 is 32 OH minus. We done 32 OH minus. While adding we can wait 32 OH minus here, and here 30 OH minus. 32 OH minus, 30 OH minus. So we will get correct answer for this. Don't get confused, it will be a little bit confusion. 30 OH minus and 3 to the 6, 15 H2O, here 15 H2O. So what will be the overall equation regarding this means, I should remove this. 8 MnO4 minus plus 3 S2O3 2 minus 32 means 2 that side 16 plus H2O gives rise to 8 MnO2 plus 6 SO4 2 minus plus 2 OH minus. This will be the balanced equation regarding thiosulfates. Thiosulfates are oxidized to sulfate. Thiosulfates are oxidized to sulfate. A little bit time takes place regarding this balancing. So to avoid that confusion, you require practice. So 8 molecules MnO4 minus required, 3 molecules thiosulfate. And similarly, one more is there, manganese 2 plus. Manganese 2 plus salts oxidized to MnO2. That equation direct you should write 2 MnO4 minus plus 3 Mn2 plus 2 H2O. 2 H2O gives rise to 5 MnO2. 5 MnO2 plus 4H plus. This equation was direct there in your text. So manganese ion salts are oxidized to Mn2 plus MnO2, and thiosulfate oxidized to sulfate. Iodides oxidized to iodate. In which medium this is? In alkaline medium. In alkaline medium this reaction takes place. So this will be the importance of the MnO4, KMnO4, and KMnO4 in volumetric analysis we don't consider KMnO4 and HCl. Generally we consider that is H2SO4. By doing the volumetric analysis to estimation of oxalic acid, we should add sulfuric acid. instead of hydrochloric acid, because of in hydrochloric acid MnO4 minus oxidizes chloride to chlorine. Chloride can be oxidized to chlorine. Due to that reason, KMnO4 versus HCl reactions are not favorable. And what about the uses of this KMnO4 means potassium permanganate is used as oxidizing agent in qualitative analysis as well as in quantitative analysis also, and it is also used as a bleaching agent for wool, cotton in textile industries, wool industry, cotton industry. It can be used as a bleaching agent and is a powerful oxidizing agent in qualitative analysis as well as quantitative analysis. By using potassium permanganate, we can estimate the amount of Fe2 plus and oxalic acid, iodides in acidic medium or alkaline medium by using the volumetric analysis. And in organic chemistry also potassium permanganate was used, that is in the form of Bayer's reagent. Bayer's reagent to cold dilute alkaline KMnO4. Cold dilute alkaline KMnO4 is called as a Bayer's reagent. This is also very important. It is treated with alkenes to give dihydric alcohol groups. So, this will be the information regarding this potassium permanganate, and potassium permanganate available in potassium permanganate is purple color, diamagnetic, tetrahedral, sp3. Manganate is paramagnetic, green color, sp3, tetrahedral. On heating of potassium permanganate, it gives us to potassium manganate plus manganese dioxide plus oxygen. So, it undergoes oxidation reactions in acidic medium as well as in alkaline medium. So, practice the equations. I hope you understood, and be confident, clear. And one more topic was there in this unit, that is F block elements. Those are very simple F block elements. So, simple means the chemistry of F block especially for that actinides it will be difficult because of moreover actinide compounds elements are what about that radioactivity elements. So, on next class we should discuss about the chemistry of F block elements, what are the general properties and what about the uses, that we should discuss on next class. So, stay with us, stay safe, be confident, clear. I hope you understood. Thank you, all the best.